So here's an example of how to do a power problem. 1,000 kilogram elevator starting from rest is accelerated upwards at 1 meter per second squared, okay, by means of a vertical cable. Find the average power supplied by the cable necessary to maintain this acceleration for 5 seconds, okay? So basically, as soon as you see power, you know you want to be thinking about work, okay? And it says average power, so we know we don't want to use the F times V1. We want to just use work divided by time, okay? Right, so work divided by time, all right? So I know the time, so that's convenient, okay? And to get the power, then I know I need to know the work. Okay, so let's just write down what we have. They give us the acceleration, for some reason, the mass, the time, and that's about it, okay? All right, so if I see that I'm going to have power equals work divided by time, I know work is force times distance over time, okay? I don't really know the distance, so I'm going to have to figure that out somehow, and I don't really know the force either, so I'm going to have to figure that out somehow. All right. Let's just draw this. What was I going to say? I forgot. Okay. All right. So let's think about the elevator. Okay. So let's draw a little force diagram of the elevator. So you're going to have that tension in that cable up and then the FG down. And since we know the acceleration is upward at 1 meter per second squared, we remember that the tension force is going to have to be bigger. Okay. It's not asking for overall the power, it's asking for the power by the cable, okay? Which means I care about this cable force. That's the one that I'm looking at, okay? I'm not looking at the whole entire situation. I'm trying to just look at the power supplied by the cable, which is the FT, okay? So if I sum my forces in the Y, okay, I'll say up is positive. So I have FT minus FG equals MA, okay? The tension would be FG plus MA, okay, which is mg plus MA, and then I'm going to factor out that M, I guess. Okay, so I have 1,000 kilograms times, I'll just use 10 here because it's not web assign. Okay, and that's going to be 1,000 times 11, which is 11,000 newtons is the tension force in the cable. All right, so that is going to be what I have to put there. Okay, I know the time already. That was helpful. Okay, but I don't know the distance that the elevator has traveled. Okay, so I need to know the distance. Okay, but you can see here I have some kinematic stuff. Okay, and I'll assume the initial velocity was 0. It probably said that. Okay, so I know I can use my kinematics stuff to find the delta x, which would be the distance. So the acceleration is 1, and it happened for 5 seconds. Whoops. 5 seconds squared. Okay, so that's half of 25, so 12.5 meters. Okay, and then that will go there. All right, so it's not really like it's anything new necessarily or hard. You just kind of have to fit all the pieces together. Okay, so when I do work over time, which is force times distance over time, my force was 11,000. My distance was 12.5 in 5 seconds. Gives me a power of 27,500 watts, right? Remember, joule per second, Newton meters a joule, over seconds, that's a watt. A watt. Okay? All right, so that's kind of how a power problem might look.